Welcome to Hidden Peels for Java High Performance Persistence. My name is Sven Ruppert and I'm developer advocate for JFrog, and I want to discuss today a few topics about high performance persistence for a Java app and how to embed, what are the good open source tools and what is the difference between them. But first of all, we want to have a look at the basic ideas, the bird's eye view, and some basic questions and thoughts, why, how, and what could be the good and the bad part. If you're thinking about persistence in Java apps, mostly you have some kind of app model already, and this app model is built for the needs of your use cases. You're constructing your entities, you have something in mind you want to process or you want to store or whatever, but the main layer is here that you are building it just in an object-oriented way so that you can handle it easily in Java. The main thing is that your data types are built on top of the core data structures and data types you have inside Java. So you're not building your own int with 7-bit or 12-bit. You're using integer, long, double, whatever, a string. And then you start composing this stuff with data structures that are already part of the JDK. I'm talking about lists, maps, queues, whatever. So you have a basic, solid, fundamental thing of types and data structures. And with this you are composing the app model, or the model for the app you just want to create. This is fine so far, but at the moment you are going down, or if you want to start dealing with persistence, mostly you start dealing as next lower level with some kind of caching. Caching is mostly if you have performance bottlenecks or it's just there and you have to use it or whatever. But caching means that you have to transform the first time your app model for the needs of this caching mechanism. Why? Caching is dealing with eviction algorithms. Caching is maybe not supporting maps, just lists, or whatever the need is that is coming from this caching layer. This is the first time you start transforming your app model for the technical need of caching. Okay, if you have done now everything for the caching layer, the next step would be finding the layer to persist all this stuff to disk. To disk means that you're dealing with different systems, mostly something like a relational database or whatever. And then this is written in a different language, is on a different machine, or is just in a different process, even on the same machine. It means that you have to transform your app model that is already customized for the caching layer to the next abstraction layer. So you have to map it in a way that it could be transferred via JDBC to the Postgre database, for example. So you have to deal immediately with latency. You have immediately to deal with different ranges of a type. So an int on one system is not exactly the same bit range of the integer in your Java world, and so on and so on. So you have to transform all this stuff again. You have to think about precision if you're losing precision, for example. And this is just a technical need, and it's a need because you have to go to a different system. And it would be perfect if you can get rid of the last two layers, get rid of the caching and can get rid of the last transformation to the persistence layer. And quite often you have applications that don't need this massive scale in terms of users. So you don't have millions of users, you have maybe just hundreds of users. And you have just a few terabytes of data. And sometimes easily can one machine or two machines handle all this stuff. So how can we deal with this one, and how can we get rid of these layers? Because this means it's a more robust application if we are just removing a few technical layers. But before we can deal with this one, we have to ask a few questions. Basic questions about the data behavior. This is not trivial, and it means that you need to know a lot about the system you're writing or the needs the system has. But some basic questions are always the same. For example, how stable is your data? This means, do you have a system that's just generating data and writing it down to disk once and never touching it again, like logs, like transaction logs or events or whatever? Is it really just something that will be created, stored and never touched? Or do you have a sliding window? For example, the last 2 hours must be available in a way that you can modify it, can delete entries, can add additional entries, and after this period it will be archived and it's frozen because it's immutable, so that nobody can change it, or it's not needed, or it's just archived. Or it's really the worst case, the whole data is hot. It means you can touch every single entity at every time, and you can delete it, modify it and all this stuff. So you have to check if maybe your system can be part the type 1 or type 2, and then you have a way easier system compared to all data is hot, the third one. How to navigate through this data? Data. If you're talking data, it means not only creating data, it means to get this data out of the store again. Is it just reading everything? Is it just reading the first 3? Or do you need something like a query language, like SQL, like Cypher for graph databases, for example? Or do you need whatever query language? Or do you are you able to deal with streams, so that you can just say, okay, here's the amount of data and I'm filtering this stuff during the time I'm executing this one? Do you need all attributes of this one? Or do you need calculated fields on the fly, like if you have A and B, please the third attribute will be the sum of those, or whatever? Do you need dynamic views, that you're aggregating different parts so that you have something like a view, a materialized view or whatever? So what is the behavior? What is really the functionality the persistence layer must give to you that you are efficient with your implementation? So think about this one. And the next thing will be just how to go through these different persistence layers. Today we want to see how to create your own test engine for JUnit 5. That means in the beginning we will have a short introduction about the possibilities of the default test engine. The agenda for today. Why we need different repositories, what's influence and what part of your infrastructure is. The next thing is why you should have an eye on it. What will this series about? It will be about